Okay, we'll see about the character data type. So character data type, for all the character data type variables, 1 byte of memory is allocated. So 1 byte is nothing but 8 bits. Okay. Now in these 8 bits of memory, okay. So what is the range of value you can store?
0 to 7.
0 to. Okay. 256. So if you are storing all these 7 bits, sorry, all these 8 bits as a 0, then what is stored in this memory? 0 is stored. 0, 1, 0. So if it is stored as a 0, 0, 0, 0, 0, 0, 1, then you are storing 1. Then you are storing 2. So like that, when it comes, so what will be stored? And all 8 bits are 111. 256. 5. Okay. So in 8-bit memory, what is the decimal value, range of decimal values you can store? From 0 to 255 you can store. Clear, right, everybody? So it is simply how you can identify is like a 2 to the power 8. It is nothing but 256. So total number of values, you can store in this 1 byte memory is 0 to 255. Total count is 256 because we are including 0 also, right? So total 256 values you can store in this 8-bit memory, that is 0 to 255. Is it clear? Okay. Now the question is, sir, I am declaring one character variable x. In this character variable, I want to store capital B as a character. Okay. For x, how much memory is allocated? How much memory will be reserved? X. 1 byte, because it's a character variable. So let's take this is your 1 byte. Now in this 1 byte, how are you going to store the capital B? How the capital B will be stored? Because see, previously we studied, sir, I have an integer variable a. In this I am storing like a 12. So for a, how many bytes of memory you have? 4 bytes of memory you have. Okay. 2, 3, 4. In this 4 bytes of memory, how this 12 will be stored? 0, 0, 1, 1, 0, 0, 0, 0. Rest all will be zeros. Correct? Am I right? Got it right? So in this A, you will be able to store the 12. 12 will be represented like this. Now in this X, okay, let's assume this is your X, 1 byte memory. In this 1 byte memory, how this capital B will be stored?
66 in the form of zeros and ones.
Okay. Okay, very good. So why 66?
Because of
ASCII value starts
ASCII starts from 65.
Okay, very good.
Capital A to capital Z.
Okay. So the characters, whatever we use in our day-to-day life, whatever characters you see in the keyboard, like special characters, alphabets, numeric characters, space, question mark, dollar, like that, whatever the characters we see, for all the character, there is a equivalent to a number. So these all characters we are calling it as a ASCII characters. And for each character there is a equivalent number, that is we are calling it as a ASCII value or ASCII number. Okay. So likewise, for capital A, the number will be 65. Capital B, it will be number 66. Similarly, like that it will go 67, 68, like that. For B, C, D, E, like that. And for small a, I think it will be 97. Small b, 98, 99, like that. So, wherever likely you are mentioning the character is converted as an ASCII number. The ASCII number will be stored in the binary form. Okay, now what is the number? 66. 66 binary is 0, 1. This is 62. 62 plus 4. Got it? So 1, 2, 4, 8, 16, 32, 64, 64 plus 4, 66. So, correct, right?
64 plus 4, 68. 2. 64 plus.
Oh, 64, right? Okay, sorry. Sorry, this is 64.
64,
64.
Right?
Got it. You're right. 64 plus 2, right? Yeah. Clear, right? Okay. So, for character X, a 1 byte memory will be reserved. After that, X is equal to B you are assigning means the B is converted as a ASCII value and it is stored like this. Binary form. Similarly, int A means 4 byte memory will be reserved. In that 12, it will be converted as a binary and it will be stored. Now, let's take here you are storing like 68. Now, you are printing printf percentage C, you are giving X. Printf percentage D, you are giving X. Okay. So printf percentage C. Percentage C means what format you are expecting to output? Character format. From which? In X. In X, you have some binary. This binary you want to print it in a character form. This binary will be translated as a ASCII number. So ASCII number is 66. For ASCII number 66, what is the character? Capital B. So it will print a capital B. Is it clear? Okay. Now, printf percentage D, capital percentage D and X.
Asking 66.
D, what format it will print?
Decimal.
Decimal. So in X, you have some binary. Forget about, sorry, X is a character. Can I print it as a like a decimal? Yeah, you can print, no problem. In X, you have some binary. That binary, you are trying to print it in a decimal form. So whatever here you have 66, so it will print as a 66. Clear, right, everybody? Okay, very good. Next, printf percentage B A. Printf percentage C A. Percentage D A. So A, whatever you are, that will be printed as a decimal number. What is the output? No, I think
68.
Here what we are storing?
68.
68. 68 means like it will be 1. 64 plus
1 plus 4.
Okay. So what will be the output here? 68. Now percentage CA. So in A, whatever you have, in this case it will take only 1 byte. For A, how many bytes of memory you have? 4 bytes you have, but it will take only the first 1 byte. So in the first 1 byte, whatever you have the number, that will be considered as ASCII number, and for that it will try to print the ASCII character. So what do you have? 68. For 68, what is the ASCII character?
D.
Capital D. Okay. 65, 66, 67, 68. A, B, C, D. Okay. So it will print as a capital D. Clear?